Okay. So today we discuss about these dynamic arrays. Okay. So what are these dynamic arrays? We'll discuss. Okay, dynamic arrays, and also we'll discuss the queues. Okay. So dynamic arrays. Once again. Yeah. Dynamic arrays. Okay. So what are these dynamic arrays? Okay. So basically there are like two times are there. One is compile time. Okay, next one is runtime. Okay, so what is this compile time? Compile time is nothing but the time where you compiler going to check the syntax error. Okay, so whatever the compiler is there, okay, compiler you are using, compiler checks the syntax error. Okay, syntax error. Okay, syntax error, that is nothing but compile error. Okay, so this evolution is going to happen. Evaluation is going to happen in the compile time. Okay, so I already shown the question sim that vlog whatever the RTL code is there we are doing. Okay, and vlog testbench we are doing. So that means you are compiling the code. Okay, you are compiling the code and checking for any errors or not. So if you are getting errors means what, you need to rectify that errors, so it will not go further. Okay, you need to rectify that errors and it will go further. Okay, so that is compile time. And next, runtime. So what is this runtime? Runtime is nothing but whatever the major operations written in initial begin and block are always are assigned will come under runtime. Okay, so basically in the Verilog, you will write the basic logic in initial. Okay, in the behavioral modeling, initial begin and block. Okay, begin and block, and you can write in like always block, or you can write in assign block. Okay, assign block, so that will come under runtime. When those instructions executing in these blocks, that will come under the runtime. Okay, so here so if you see the arrays. Okay, so arrays, there are like so fixed arrays we already seen. Fixed arrays, in that you have packed arrays and unpacked arrays. Next is dynamic arrays. What are those dynamic arrays? Okay, so that we'll see. Okay, so dynamic arrays, we'll see the dynamic arrays. Dynamic arrays. Dynamic arrays are like the syntax. Okay, syntax is what? Syntax is uh, data pointer, and array name. Okay, array name, and you need to give this square bracket that is empty. Okay, there is no size in the fixed array, so you indicated means you indicated the size within the square bracket. Okay, but in dynamic array you need to allocate the size. Okay, suppose example, if you take example int dynamic array, dyne underscore array, let us take this is square bracket. Okay, there is no size. Okay, so that means in the dynamic array, during compile time, no memory is created. Okay, so when the memory is created, during the runtime. Okay, memory is created during the runtime. Okay, so no memory is created. Okay, so that means memory, when the memory is created in the dynamic array, memory is created during runtime. So that means runtime, I already told, no, whatever the blocks which are executed in this one. Okay, those are nothing but runtime. Okay, so this is about the dynamic arrays. Okay, dynamic arrays. Okay, during runtime only, whatever the memory is there, that will be that will be created. Okay, so we'll see some programs related to dynamic arrays. Okay, one second, yeah, I'm opening. dynamic arrays. Okay, these are the some programs I wrote. Let us take delete copy dynamic array 1. Okay, dynamic array 1. This program I wrote in GVim. Okay, so here if you see, okay, so here what is this module dynamic array 1? I told you, no, so int is a data type dyne1, and you should not declare any variable. Okay, that is dynamic array initial begin. Dyne1 equal to what? New. So I need to use a new. Okay, new. So new means what? It will create a new memory location, dynamically allocating how many spaces, five memory locations for the 5 integers. Okay, so that is you need to use a keyword for dynamic array new. Okay, and next, I can use this method dyne1 equal to what? I need to use this initialize the dynamic arrays using array literal. Okay, tick off this flower bracket 1 2 3 4 5. Okay, so dyne1 I am displaying with this one. Okay, so this is nothing but in last class we already seen array aggregation method. Okay, this is nothing but what? Array aggregation method. By using array aggregation method, I am initializing these values to the dyne1. Okay, and I want to display the values, that is dollar display. The value of dyne1 is %p dyne1 and end module. Okay, so this is the basic program for dynamic array. Okay, so this I am executing in my EDA playground. Okay, meanwhile you can execute in QuastaSim also. In your free time you can execute in QuastaSim. Any doubt you are getting, just ask me. I will try to rectify. I will rectify that out. Okay, see here, so that means this is EDA playground, and whatever the design is there I need to write here, and here I am writing the test bench. Okay, mostly in SV we are writing the test bench only. Okay, so this I am copying, and go to the tools, select the tool Alt Rivera, and run this code. Okay, if I run this code, what I will get, see here, kernel, the value of dyne is what? The value of dyne, 5 memory locations are allocated, and after that 5 memory locations are stored in where? 1 2 3 4 5. Okay, so that means here dynamic array, the memory location is not created during the run compile time. So when it is created, so I wrote the logic in initial and begin and block, no. So during this whenever this is executing, that memory location is created. Is it fine? Shall I move forward?
Yeah.
Okay. So
Yes.
this is about the first program, and second program you see. Okay, second program. So this is the second program. Let us see this one. Select the font size. Okay. So here what I can do, like I want to copy, I want to copy these values. Okay, suppose I am initializing, so dynamic array dynamic array 1, int dyne1 and dyne2 I am initializing. So two dynamic arrays I am initializing with integer data type initial begin. Dyne1 equal to 5 I am giving, and dyne1 equal to what? These values I am giving it to dyne1. This we already seen. This is nothing but copy operation. Copy operation is nothing but what? Whatever the values present in the dyne1, I am I'm pasting into dyne2. Okay, I'm pasting into dyne2, and here I'm checking whether it is copied or not. Okay, so whether it is copied or not I need to check. So here I can use dyne2. So I will check why so dyne2 is coming, is copying or not I need to check. And after that again I will initialize dyne2. Okay, so dyne2 I am initializing, and I am checking whether dyne2 is updated or not. Okay, just this is nothing but copying operation. Okay, here I am doing whatever the content present in the dyne1 I am copying into dyne2. Okay, just copying. Okay, so this I will copy and check in the EDA playground. Just run this program. See here, what happens, whatever the values present in dyne1, that is copied into dyne2. Okay, dyne2 equal to dyne1, no? Dyne2 equal to dyne1 means, so here, 1 second, I will do one thing here in this what I will do, Okay, in this just uh, I will comment this. Just I will run this. What output I am getting, I want to see. So that means the memory elements are copied from DIN 1 to DIN 2, no? The value of DIN 2 is equal to what? So DIN 2 equal to DIN 1. So DIN 2 equal to DIN 1 means what? Here the memory elements are copied from DIN 1 to DIN 2. Okay, this copy operation is happening. And after that, so I am updating the value of DIN 2. Okay, so that means is there any copy elements are overwritten? Okay, overwritten, that I want to see. Okay, so just after copying, I am running this. So if I run this, first this is nothing but what? Copy operation. This is nothing but copy operation. After that, I am updating the value of DIN 2. So if I am updating the value of DIN 2, whatever the previous values are there, that is overwritten, and this will be executed in DIN 2. Okay. So this is some one type of copy operation. Yeah. Okay.
Yes.
Okay. Next you see. Next this operation. See here. So next this is nothing but first I am initializing so DIN 1 and DIN 2, and DIN 1 I am initializing as five memory locations, and I am initializing with array aggregation method, and whatever the DIN 1 is there I am copying into DIN 2 and I am displaying. After that I am updating these values and next displaying. After that I want to allocate 10 more locations to DIN 2. Okay, 10 more locations to DIN 2. So what it will do, this will erase the previous elements and create 10 locations. Okay, so this we will see. Okay, so when you allocate 10 more locations to DIN 2, what happens, this will erase the previous elements and create 10 locations. Okay, so we'll see. Okay, what output we are getting, we'll see. Okay, okay, see here. So you copy the, if you paste this, and if I run this, yes, first what happened, this operation is performed. That means what, so that means that is copied. Okay, so copied with so you can here you can like the value of DIN 1 is this one, the value of DIN 1 is this one. Okay, our copy operation means if I want to execute DIN 2 here. Okay, DIN 2 if I run, so the value of DIN 1 is copied into DIN 2. Okay, here also I need to keep DIN 2. Here also I need to keep DIN 2. Okay, so if I run this, so what I am getting, whatever the value of DIN 1 is there, that is copied into DIN 2. So the DIN 2 is what, 1 2 3 4 5. After that I am updating the value of DIN 2. So values are updated, and after that DIN 2 equal to what, DIN 2 equal to new of 10. So new of 10 means what, whatever the previous values are there. So previous values are 5 6 7 8 9, those are updated. So those are updated with how many locations? 10 locations. Okay, that will be erased, and the 10 elements are created. So these are initialized to 10 locations. These are initialized to 10 locations. Okay, so this is nothing but we can erase the previous elements and we can create the 10 locations. Okay, so this is about creating the 10 locations. Okay, and next array 4 you see. So this is one more program. Like this we can see in the Questa sim also. Okay, uh, so so directly that process will be not there. Directly we can see the outputs in EDA playground. Okay, so if you want to practice, we can use this EDA playground. Okay, so here what happening, like a copying operation, and after that updating the value of DIN 2, and next DIN 2 equal to new of 10 DIN 2. Okay, so this we will see. Okay, new of 10 DIN 2, DIN 2 I am giving. Okay, new of 10 DIN 2 I am giving. Okay, and I want to display this, what happening we'll see. So Control C. Okay, one second here. Just I'm copying this, I'm pasting it here in EDA playground. Okay, I'm running this code. So here what happens, same thing, this is same thing only we already seen 1 2 3 4. This is copying operation and this is updated operation. Dyn2 equal to new of 10 dyn2. So dyn2 equal to new of 10 dyn2 means what? It will erase the previous elements and create so not this one. So that means in this 10 locations, these locations, whatever the 5 locations are there, that will be there, and remaining 5 locations will be cleared, will be like updated with new locations. Okay, that is nothing but this function. Okay, new 10 dyn2. So dyn2 will be there, dyn2 values will be there. So for what is dyn2 values? 5 6 7 8. Okay, 5 6 7 8. Suppose if I will change, okay, suppose if I want to change the values, okay, some 10 11 12 13 14 and 15. Okay, just I will see, okay, whether I am getting the this one or not. So I got these values, no? So value is updated. Okay, updated these values. After that, this 5 values will be available, and this remaining bit will be updated with these zeros. Okay, these zeros. Okay, like that. Okay, and next. Next is what? Array delete. Okay, array delete. Array size we'll see first. One second. Array size, array copy. Okay, just we'll see the array copy. This is copy only. Copy we already seen, no? Copy operation we already seen. Okay, array delete. Array delete means what? So here array delete means, so here I'm initializing two values. Okay, dyn1 and dyn2. I'm initializing dyn1 with 1 to 5, and I'm copying these operations and updating. Okay, and dyn2. Okay, and I want to display the array size. Okay, I want to display the array size. So for this array size, what I can do, I can dyn2 dot size of this brackets. This is the function. Okay, I want to see the function. Okay, or array size, how much size is there. Okay, so these are nothing but related with index. How much size is there? This is total, how many elements are there. Array means what? A set of elements. How many elements are there? 5 elements are there. Okay, to delete some dynamic array, we need to use dyn2 dot delete. Again I need to display the array size as well as the value of dyn2. Okay, so this is nothing but I want to check the array size as well as I want to delete the whatever the array is there, and again I want to check the array size as well as I want to see the content of this elements. Okay, so this I will execute. So just copy and here you paste. Okay, run. See here what I got. First anyway this we already seen, dyn1 equal to what? 1 2 3 4, and dyn2 updated. Okay, 5 6 7 8. After that what is this function? That means this function also we already seen. So that means here 5 6 7 8 9, and the remaining are allocated with new locations. Okay, after that what is the array size? Total how many elements are there? 10 elements are there. Okay, array size. Okay, it will display the array size. Okay, display the dyn2 dot size, array size. Array size is 10. Okay, after that I want to delete. Okay, total array. So dyn2 dot delete. So I need to delete all the elements in this array. So when I want to delete all the elements in array, what I need to do? So that means it deletes all the elements. So I want to display the array. So that means the size of the array equal to what? I want to display the size of the array. Size of the array is what? 0. Okay, and I want to display the content in the array. Okay, content in that array. There is no contents are there, no elements are there. So the value of dyn2 is what? So that means empty flower bracket. empty dollar bracket. Okay, is it fine? Simple to understand, no?
Yeah.
Okay, yes. Next, array size. Array size, same thing. Array size means, as I told you, know. So in the previous program only it's covered array size. Okay, array size. So just same thing. Just copying and updating, and this one. Just I'm checking the array size only. Okay, so that is covered in the previous program only. So here just I'm pasting, run. 1 second, it is copied or not? 1 second. Mm, array size, no? Array size, edit, select font size, copy. Next, I'm pasting in this. Just run this. I want to check the array size. Okay, I want to check the array size. Same thing, no? So total, how many number of arrays are there? 10 elements are there. So 10 elements means it will check. So array size is how much? 10 you will get. Okay. This is about the dynamic arrays. All programs we checked. Okay, dynamic array 1, array 2, array 3, array 4, and array size, array delete, array copy. Is it fine? Any doubt in the dynamic arrays?
No doubt.
Oh, okay. So next we'll come with queues. Okay, queues. What is this queues? Okay, so those are dynamic arrays. Next, queues. So queue. So queue, you have idea, I think so. Like you have stacks and queues, no? So queue. What is queue? Queue equal to queue is there is FIFO. I think FIFO we already discussed in Verilog, no? So that is what first in first out. First in first
Yeah.
out. Okay. FIFO we already told. Okay, that is FIFO full, FIFO empty. Okay, FIFO depth calculation also we already seen. Okay, and next is LIFO. LIFO means what? Last in first out. Last in first out, LIFO. Okay, so what is the syntax for this? Queue is also easy thing, easy one, easy to understand. Just syntax. What is the syntax? Data pointer, queue name, queue name, queue name, and this will be. So initially we already seen that dynamic arrays are represented with empty square bracket, no? This queue is represented with dollar. In this square bracket, dollar. Okay, in this square bracket, dollar. Okay, so queues are two types. One is bounded queue, and unbounded queue. Bounded queue and unbounded queue. Okay, so that means here so we can access the index. We can access in the random index is possible in the queue. Okay, we can access the random index. Index is nothing but what that value in this. Okay, so like suppose if it is a queue, this is a queue. Let us take this is a queue. So we can access the, so like suppose we can push from back. Okay, we can pop the queue from back. Okay, we can push the elements from the front, we can pop the element from the front. Okay, so like we in the queue we have like a push operation and pop operation. Push and pop means what? Just whatever the element inserting, that is nothing but push operation, and elements taking is nothing but what? Pop operation. Okay, so here we already seen like dynamic array. In dynamic array, we are allocating the memory in which we are allocating the memory in during the runtime. No, already told. In dynamic array, when we are allocating the memory, we are allocating the memory during allocating the memory during runtime. Okay, memory during runtime. During runtime. Okay, whereas in static array, like we have packed array and unpacked array, no. So in static array, we are allocating the memory during which time? Compile time. During compile time. Okay, but in this queues, okay, in this queues, we are not explicitly are not going to create the memory. Okay, we are not going to create any memory. Okay, we are not going to create any memory. So that means here we are creating the memory in dynamic array as well as static array. Okay, so in the dynamic array we are allocating during the runtime, and in static array we are allocating the memory during the compile time. But in static array we are not allocating any memory. Okay, we are not allocating any memory. Okay, so so how to declare this declaration of like so here if you see unbounded queue. What is unbounded queue? So unbounded queue means there is no limitation in the size. Suppose this is a queue, this is nothing but queue. Okay, so what is unbounded queue? Unbounded queue is nothing but there is no limitation. Okay, there is no limitation in the size. Limitation in the size. Okay, in the size. Okay, limitation in the size. Okay, so how to declare this unbounded queue? So declaration of unbounded queue. Okay, how to declare this unbounded queue? We'll see. So see here. Yes. So declaration of unbounded queue. Declaration of unbounded queue. So how to declare this unbounded queue means int q dollar in the square bracket dollar. Okay, this is unbounded queue. This is what declaration of unbounded queue. There is no like I told you, no, there is no limitation in the size. Okay, unbounded queue. Unbounded queue. What is bounded queue? So int q is dollar down to 2. Dollar down to 2. Okay, so that means this is bounded queue. This is what bounded queue. Bounded queue means what? There is some limitation in the declaration. Okay, it have how many locations? It have 2 locations. 2 locations. Okay, this is nothing but bounded queue. Okay, bounded queue. Okay, so we are going to see like some programs related to this. Okay, we'll see. Okay, queue. These queues are also simple only. You can easily understand. First class I told you, no, SV is easy only. If you understand in a proper way, you can it's a easy language. Okay. How to insert the values into the queue? First we'll see this. Okay, so this one you see module unbounded queue. So how to initialize the unbounded queue? This is unbounded queue. Okay, so this is without any limitation. The memory you are creating a unbounded queue. Okay, int q dollar. Okay, in the square bracket initial begin, and initializing the queue. Q equal to what? By using this this method we are initializing. Okay, queue insert I want to insert these values into this queue. Okay, queue insert, and I want to display. Okay, so queue insert, queue dot insert, this is nothing but what, this is the index value, and this is nothing but what, this is actual value you want to insert. Okay, so basically like if you see this program, one second, yes, so if you see this program, my elements are what, 1 2 3 4 5, these are my elements. Okay, what are the index, 0 1, next 2 3 4. Okay, here what I did here, this is dynamic array. Okay, this I want to insert q dot insert equal to 1 comma 0. So 1 comma 0 means what, so 1 comma 0. Okay, 1 comma 0 means this is index, this is the, whatever the value I want to insert, value to insert. Okay, so that means index is what, this is the index, 1 is the index. Okay, in this 1 index in between I want to insert what, 0. Okay, uh, did you got the concept how I am inserting? First one is nothing but what, index. First one is nothing but index, next one is nothing but the value that want to insert. Okay, so just we'll see what output we are getting. So this one, just copying, insert. I'm seeing in EDA playground. Okay, so I'm running this code. Yeah, you see here. So that means here I told you, no, so from where you need to insert, so from where you need to insert, that means 1 2 3 4 5. Okay, so here that means this is the first value is what, index value. In this, in between this index value is 1, in between I need to insert which value, 0 value, 0 value. After inserting, what is my value, that is 1 comma 0 2 3 4 5, this is my value. Okay, so I got the output, 1 0 2 3 4 5. Okay, this is nothing but insert. Okay, insert. Okay, and next so next in the queues, you have some operations are there. That operation, what are those operations, we'll see. So yes, so in queue, first one is delete. First one is what, delete. Okay, first one is delete. Okay, delete. One second. Delete. Okay, delete, these are the functions. Okay, so what it will do, it will delete entire queue, it will delete entire queue. Okay, delete. And next size means what, size means it is going to give the size. Okay, queue. Okay, it is going to give the size of the queue, okay, size of the queue. Okay, and next as I told you, no, like in the queue, so what I can do, this is one queue. Okay, this is one queue, set of elements are there. Okay, in this I can push from front. Okay, that is nothing but what, push front. Okay, I can pop from front, this is what, pop front. Okay, and I can pop back. Okay, I can do push back. These are the operations I can do with the queue. Okay, So what are the functions? What are the predefined functions? Those are one is what push underscore front, push underscore front, and next one is push underscore back, push underscore back. Okay, and next pop underscore front, pop underscore front, and pop underscore back, pop underscore back, and the next insert also we already seen, no, insert. So insert means what? Insert we already seen, now itself we already seen insert. Okay, insert. So how we can do like insert? This one is insert index comma value, index comma value. So these are some built-in functions of a queue. Is it fine? Should I move forward? Hello. So this
Hello,
is
am I audible?
yeah, you are audible. Yes.
Yeah.
Yeah.
Okay.
Okay. Yes. So here these are the built-in functions of queue. Delete the entire queue size. It is going to display the size of the queue, and we can do 4 operations. That is push front, pop front, push back, pop back. Okay, these are the inbuilt functions, and you can insert the values into the queue. So how it will be then means index comma value, index comma value. Okay, so some programs we'll see. Insert element we already seen. Delete we'll see. Okay, delete we'll see. 1 second, it's not opening. Yeah, this is delete function. So if you see, so here what happens, module q delete, module under q underscore delete. So I am initializing q int q dollar. This is unbounded q initial begin. Q I am initializing q equal to 1 2 3 4 5. Okay, so delete the q dot delete 2. Okay, so in bracket this is nothing but index value. Okay, index value means which element I want to delete. Delete the element at index 2. So the index 2 means what? 0 is at index 0, 2 is at index 1, 1 is at index 2, and 2 is at index 3. So here I want to delete at this queue. Okay, I want to delete this element. Okay, so delete 2 means what? Delete 2 means I want to delete that. Okay, delete the element. Okay, so like so here 1 2 3 4 5. Okay, so here what is the index? It will start from 0 0 1 2 3 4. Okay, so here delete dot 2 means what? At this index I want to delete this element, I want to delete this element. Okay, so this one I want to execute. Just copy this. Okay, copy this, and next just paste in the EDA playground, run this. Yeah, third element is deleted now. The value of q is what? 1 2 4 5. So that means here the element which is related to index 2, that is deleted. Okay, that is related to index 2, that is deleted. Okay, so this is about delete function. And next push size of the queue we'll see. Okay, size of the queue. So this is size of the queue. Just it will give the size of the queue, how much how many number of elements are there, it will give the size of the queue. Okay, just we initialize the queue. Okay, 1 second, queue you need to give it with dollar, no, unbounded queue. Okay, unbounded queue, unbounded queue. Just copy, so save this. Okay, Just I'm pasting and running this code. Yeah, the size of the queue is what? 5. The size of the queue is 5. Okay, so this is size of the queue. And next ordering we'll see. Ordering, just it will show order like ascending order, descending order, that will show. We'll see. Okay, unbounded queue initialized. This is value of queue, it will show. And it will sort. Okay, it sort means what? Sorting. Okay, like if I want to, sorting is nothing but ordering, no? So like arranging the given numbers in either in ascending order and descending order. So just randomly I will give the values. Okay, so that I can check the values. Okay, so 1 3 2 comma 5 comma 4 I'm giving. Okay, so I'm saving this. That is sort. Reverse sort we'll see. And that is reverse. Shuffle means what? Shuffle means randomly it will shuffle. Okay, so or you can give like this. Okay, we'll see what output we are getting. So here if you see the output, run this. First, the value of key is what? The value of key is whatever this value is there, that will be displayed. Okay, first this value will be displayed. Okay, 1 3. The value of key is what? 1 3 2 5 4. Okay, after that sort. Sort is nothing but what? It is arranging the given elements in form of what? In form of ascending order from smaller to larger. Okay, smaller to larger. That is nothing but sort. Sorting is nothing but you are arranging. Okay, and next R sort. R sort means what? It is arranging in descending order. It's arranging in descending order. Q dot R sort is nothing but it's arranging the given values in descending order. Okay, and next next is what? Next is reverse. Yes, reverse means what? Here you got the elements are nothing but what? 5 4 3 2 1. No, after that if you want to reverse, it will again it will execute like reverse means what? One will come first, second, 1 2 3 4 5 like that. Okay, so after arranging in descending order, it will it will reverse the given elements in sort. Okay, so this is nothing but reverse. Okay, and next shuffle means what? Randomly it will allocate the elements. Okay, so this that q dot shuffle equal to what? Randomly it's displayed 5 2 1 3 4. Randomly it is displayed. Is this built-in functions are fine? Do you understood? Waiting for your response. Shall I move forward? Yeah.
Yeah, I'm talking. Am I not? Am I not audible?
You are audible
Hello.
now. You are audible now. Okay, okay. Sure, sure. I think some network issue. Okay, okay. My voice is clear, no? Yes,
Yeah,
fine.
your voice is clear. Yeah.
Okay, okay, sure. Okay, thank you. Okay. Next, yes. Next, insert over, delete over, pop back, push back. We'll see. Okay. Pop back. This is what pop back. Okay. First what operation is there in this? Push front. We'll see. Okay. So we'll come order wise. Push front. Push front. So Q push front. So this is push front. So this one what I can do, like I want to insert the element from the front. Okay, I want to insert the element from the front. Okay, so my elements are nothing but 1 2 3 4 5. Okay, I'm initializing. After that, push the new element. Okay, push the new element from the front, that is 3. So 3 will be pushed from the front. Okay, I want to display these elements. Okay, so here what I can do, so I'm copying. I'm copying. Just you paste in EDA playground. Okay, so it's easy to see the outputs immediately in the EDA playground. Okay, you can practice these test bench codes. Okay, see here. the value of q is pushed into this so initially what is the value, what a value of this one is 1 2 3 4. After push operation 3 is pushed from the front, okay, 3 is pushed from the front, okay, push front, and next we will see push back. Push back, where is push back, second, push front to push pop back, okay, q, pop back, pop front, push back you can see, okay. So in this function only what I can do, so here I will use the function push back, okay, push back, just run, okay. So back 3 is pushed, 3 is pushed, okay. Similarly pop front, pop underscore front, pop underscore front, okay. Just I am changing here itself, okay. So just I am running this program. I think that element is not there, no. Suppose pop I need to remove that element, no. So first element it will, q means what, first in first out or last in first out. So first element pop front, from front I need to remove the element, okay. So pop front, one second, it is giving error, I need to see pop front, one second, okay, okay. Pop front means what, pop front means you should not give any value, okay. So directly you can give this this argument I should not give, just run this function. Yeah, one is popped, no, one is popped, okay, popped from the front, pop back, run, see here 5 is popped, okay. So like this, these are easy operations, you can remember and you can do some practice, okay. These are about this dynamic arrays and pop queues, okay, dynamic arrays and queues, okay. Yeah, next class we'll see about associative arrays, okay, associative arrays that we'll see, okay, associative arrays, if time permits we'll see functions and tasks also are there, okay, functions, okay, functions and tasks also there, okay. If time permits we'll see the functions and tasks also, okay, tasks and functions, okay. Tasks and functions we already seen in this Verilog, no. So in the
Yeah.
system Verilog we are going deep into that. Why? Because most of the time we are working with functions only. In the system Verilog we'll working with the functions only, okay. That's why we need to go into the deep into that tasks and functions, okay. Okay, I'll start the recording.